Welcome to aminacademy.com. Let us do Tamil Nadu Higher Secondary Second Year Maths Textbook 2, Exercise 7.6, Question number 2. Find the intervals of monotonicities and hence find the local extremum for the following function. Number 2, f of x equal x over x minus 5. Here the second question, f of x equal x over x minus 5. Here f of x is defined and differentiable for all x is an element of R except 5. Means here denominator have the function denominator have x minus 5. If you substitute 5 minus 5 is 0, its infinity comes, so it's not defined for 5. So x is an element of all real number except 5 is our domain. Now we'll find f dash of x, that is derivative of f(x) by uv, quotient rule, x minus 5 square. Here x minus 5 into derivative of x is 1 minus x minus 5 derivative of x is 1. So which is equal z x is that is x minus 5 not x minus 5, here x only, derivative of x minus 5 is x first and derivative of x minus 5 is 1. So x minus 5 minus x over x minus 5 the square. So we have f dash of x equal minus 5 over x minus 5 the square. And we have f dash of x0 I had to equate, which gives minus 5 over x minus 5 square equals 0. Therefore here, but we cannot, that means it is having minus 5 is equal x minus 5 square, which is not possible. So there is no stationary point, because here we cannot get the values for x here. We can say there is no stationary point. Therefore there is no stationary point in this situation. The possible intervals are minus 5 to minus infinity to positive 5 and 5 to infinity. Now we'll put this, we'll fill the table. Now look at this table here, this interval, this of minus infinity to 5 and 5 to positive infinity. Here sine of f dash of x here. So in between minus infinity to 5, we can say x equal 0. Then we substitute f dash of x is minus 5 over x minus 5, 0 minus 5 square equal minus 5 over 25, which is a positive sign. And here for 5 to infinity, say x equal to 6, we substitute in f dash of x 6 minus 5 the square equal minus 5 over 1 is negative sign. So we can say here strictly decreasing, here minus sign, sorry, here minus, strictly decreasing here also strictly decreasing. Therefore we can conclude f of x is strictly decreasing f of x is strictly decreasing on minus infinity to 5, both in that, and 5 to infinity. Since there is no stationary point, there is no stationary point, that means we didn't get that the curve does not change its position. The curve does not changes its position. Therefore, hence there is no local extrema. Hence, there is no local extrema. Next question number. Next question number is third one. Function is here, given function is f of x equal e power x over 1 minus e power x. F of x is defined and differentiable in minus infinity to plus infinity, and therefore you can say f dash of x will do by uv, quotient rule, 1 minus e power x squared 1 minus e power x into e power x derivatives e power x minus that e power x into minus e power x, which equate to 0, and simplify, we'll get finally 1 over 1 minus e power x square equal, because in numerator simplified becomes 1, denominator is 1 minus e power x whole square e power x. Now if f dash of x equal to 0, which gives 1 minus e power x the whole square is 0, here it is not possible to find, because 1 minus e power 1 over e power x whole square is 0, means here 1 equal to 1 minus e power x whole square equal. It is not possible. So we have 1 over 1 minus e power x whole square is not equal to 0. Therefore we can conclude there is no stationary point. There is no stationary point. Therefore f of x is f dash of x equal f dash of x equal 1 over 1 minus e power x whole square is greater than 0 for all x is an element of minus infinity to positive infinity. That means if you put f dash of x is 1 over 1 minus x whole square, it must be greater than 0 for minus infinity to plus infinity limit. There is no stationary point. The curve does not change its position. Therefore, the curve does not changes its position at any point. Because there is no stationary point. Therefore, you can say hence there is no local extremis. Hence there is no local extremum. We have done. Please subscribe our YouTube channel.